Welcome, everyone. Thanks, everyone, for joining. I'm just going to give it another minute or so for more people to trickle in. But as you are joining, if you wouldn't mind putting in the chat where you're tuning in from. Great. Looks like a lot of people have joined. We might be at critical mass, so we can probably get started in just a second.
Okay.
See folks from all over the state, which is great. I'm joining from our office in Winooski. Great. Well, it looks like we have critical mass, so I think we should go ahead and get started. We have a pretty packed agenda for tonight's webinar. So again, thanks everyone so much for joining us for this button-up webinar on heat pumps. Is a heat pump system right for you? My name is Bekah Kuster. I'm a community engagement manager with Efficiency Vermont and help to facilitate the Button-Up Vermont campaign. And I'm joined by some of my great colleagues, Bob Kogut and Steve Spatz, who are really going to be leading tonight's presentation. But before I do turn it over to them, just wanted to go over a few logistics and a few intro slides, but we'll go ahead and get into the content. So first, just wanted to introduce who Efficiency Vermont is. We are the statewide energy efficiency utility, which means that we help to reduce the cost of energy for all Vermonters and really help folks understand and make better use of energy and reduce greenhouse gases. And we do this in a lot of ways, many of which we'll talk about in today's webinar. But one of those ways is education, which is why we're all here tonight for this webinar. We also help to facilitate and sponsor the Button Up Vermont campaign, which is Vermont's annual campaign to help Vermonters prepare for winter. It is really a statewide collaboration of so many different partners that make this campaign possible, including utilities and weatherization agencies, town energy committees, a ton of folks that participate each year. If you're interested in learning more about the ways that you can prepare for winter and all the resources that Button Up can provide, you can go to the website here, buttonupvermont.org, and check out all those resources. The last thing I wanted to share is that we are doing a gift card raffle. So one lucky attendee from tonight's webinar will be randomly drawn to win a $50 gift card to a local hardware store. So we'll do that drawing after the webinar, but just know that if you're that lucky winner, you can expect an email from us. The last thing I wanted to note is that we are recording this webinar and it will be available afterwards. We're going to send it to all registrants along with the slides. So don't feel like you have to take a ton of notes. All of this content will be available to you afterward. We have a lot of content. So we want to make sure we can get to as many of your questions as possible. So we're asking that when questions come up, please feel free to put them directly in the chat. We have some of my colleagues in the chat who are going to be answering questions as we go. And then at the end, we'll hopefully have 10 or 15 minutes for questions. We're going to start with some of the kind of themes and questions that came in during registration and then try to answer any unanswered questions in the chat. Also wanted to note that we know folks have very, very specific questions about their home. And while we want to be able to answer those, these are really a challenging forum to answer those questions. So we'd recommend that you follow up with us. There's a lot of ways that you can connect with us, either giving us a call or setting up a virtual home energy visit, which I know Steve is going to speak to, but there's definitely ways that we can support you, but it's really challenging for us to kind of get a good sense of your home and your situation in a forum like this. So with that, I'm going to turn it over to you, Bob, to kick off the content.
Great. Hello, everyone. Thanks for joining us. So we can skip to the next slide, Becca.
Bob, do you have control? You can move them if you want,
Thank
but I'm
you.
happy
I'll do
to
that
move
from
them
now
if
on.
you.
I forgot
No
I had
worries.
it. So,
No worries.
So what we're going to cover kind of in this presentation is a brief overview of common heating systems in homes, especially in Vermont. Kind of describe and explain a bit what a heat pump is and how they work. Go over the different types of heat pumps that are available for home heating and what might be suitable for your home, what you should be thinking about. And then the next steps, what you should ask your contractor, other resources that are available to you to move forward with evaluating heat pump for yourself. And I will click myself. Okay. So good place to start is to think about like, what are your goals? And those goals might be, I want to reduce my energy costs. Those goals might be that I want my home to be more comfortable. Goals might be that I want to reduce my greenhouse gas emissions. So, knowing that up front and prioritizing those goals will help you when you're talking to either Efficiency Vermont later on or talking to your contractor. Think about what your comfort needs are. Your house, do you have a minimum temperature that you've always got to hit? Do you need cooling in the summer? And then, think about and talk to your contractor about what your current kind of system is. What's the distribution system for your heat? Do you have forced hot air, or do you have radiators? Do you have, in-floor radiant? And then, what's the state of your house in terms of weatherization? Have you done weatherization? Have you done air sealing? Have you done insulation improvement out in the home? All those things are very important in deciding, like, kind of, is a heat pump a good choice for you, and what kind of system is going to work best. And also, what is your budget? Obviously, think about that. So the next one. So just kind of a quick overview of some traditional heating systems are. Fuel-fired heating systems are the most common that people have. And in Vermont, it's likely oil, could be propane, or it could be natural gas. Those are the most common. But there's also, wood, pellet, and other types of burners. Okay, so going over boilers, what's a boiler? A boiler is the furnace that burns a fuel of some sort to create the heat energy to distribute around your home. Again, that could be oil, propane, something like that. Generally includes pumps and valves to move the fluid around and to move the fuel to the burner. Pipes to move it, to different areas in your home, and then a way to get that heat out into your living spaces, which again is like radiators, baseboards, like I mentioned before, heated floors. Sometimes those heating systems with boilers also will provide hot water for you. So, types of furnaces. Which one's this? Sorry. So this is talking about a forced hot air. So if you have a forced hot air system for a fossil fuel furnace, typically a furnace often in your basement or other place that burns the fuel, creates the heat, and then you have blowers and you have a duct system throughout your house to kind of send that heat around. There are air filters in there to kind of improve the air quality. And then various types of like grills, diffusers, registers that could be in your floor, they could be in your ceiling, downdrafting, various places. Another way of heating homes often is space heating without distribution. So that would be like a Rinnai heater that you might have, obviously like a wood stove, pellet stove. Those are common as well for heating homes, either individual and sometimes entire homes are heated that way. So what's the difference, like with some characteristics of a fuel-fired heating system that might be different from a heat pump? Generally, they're very high heat, high temperature distribution systems, meaning like, those furnaces that are burning a fuel are creating, a high heat load, which we'll learn later is a little bit different than how a heat pump operates. Obviously, they don't provide any cooling. And you are subject to fuel pricing, which can change a lot. Oil, propane, and even natural gas kind of prices fluctuate quite a bit. And all of those systems, any system that burns fuel is creating carbon emissions and other pollutants related to combustion, which, a properly designed system is generally not a worry inside your home, but can be a risk when you're burning a fuel like that in your house. So what's a heat pump? Get into that. So heat pumps run entirely on electricity. They can provide cooling as well as heat, and they're far more efficient than electric resistance heating. Typically 3 times as efficient, between 2 and 5 times as efficient. It depends on what the outdoor temperature is. There's a lot of other factors, but heat pumps have sort of a magic technology. It's not magic, it's physics, but they can move heat from one space to another. So they can move heat from a cold area of the outdoors in the winter into your warm house and make it warmer still. So how do they work? So a heat pump uses a refrigerant cycle. So it's the same kind of physics that would be in your refrigerator. It's the same physics and kind of general parts that would be in a window air conditioner. And what it's doing is using a working fluid, like a refrigerant fluid, and it's pumping it in this continuous loop. So there's a compressor that compresses this fluid and brings it out to a condenser. This one's just showing us in heat mode here. Sorry, let me skip ahead and go right back. Okay. All right. So the interesting thing about a heat pump is essentially, and like I said, the same as a refrigerator and air conditioner and how it operates, but it can be run backwards. That's kind of like the magic that makes a heat pump different. It has a series of valves in it that allow you to reverse the fluid flow within the device to run backwards or forwards. In one direction, it provides heat. In one direction, it provides cooling. Skip ahead of some of the physics here. So how do they work? Another thing about a heat pump is it generally has an outdoor unit and an indoor unit. So the outdoor unit is there. It has a radiator in it. It has a bunch of fins, just like you'd have a radiator in a car. And depending on what mode it's in, it's either expelling heat to the outdoors to get rid of it, heat that it's pulled from your house, or in the other mode, it's pulling heat from the outside, and the radiator on the inside unit is providing that heat to the inside of your home. So a lot of these, sorry. This is showing it, just popped up when I clicked forward on there, showing you a little bit, some graphics. We'll see some actual pictures later, I think, of what some of the units look like. But on the left there, you see that unit with the fan on it. That's an outdoor unit, which has got, generally it has a fan, and it has a radiator in it. Again, it can provide either heating or cooling depending on which direction you're running it. On the inside, you see like a typical indoor unit for a heat pump system that's generally mounted up on your wall. That's that white thing in the blue box up there. And that again has a little radiator in it, in which that working fluid is flowing through, and it can either pump out heat or provide cooling. So interesting, heat pumps have gotten a lot better in recent years, to the point where they can work even in cold Vermont winters. So heat pumps now can effectively heat your house, or effectively produce heat even when it gets below zero outside. And that's come through like a lot of kind of technology advancements that have happened pretty quickly. Let's see, so I'm going to go forward on that. So now I'm just going to kind of go over quickly what the different types of heat pumps are. So these are the main four categories that are listed up on the screen here. So ductless is also called the mini split. That is a unit designed for space heating in a single area inside your house, like a room, or if you got an open plan kind of house, it'll heat, it can heat that area depending on how you size it, what its capacity is. A ducted system uses a heat pump to and is always coupled with a duct system. So if you've got a forced hot air furnace system now, which might be propane or oil or natural gas, a heat pump uses the similar distribution system or the same distribution system to move warm air out throughout your house, out through those registers. Air to water heat pump, that means that it's got an outdoor unit like those pictures we saw earlier, where it's drawing heat or expelling heat from the outdoors in that outdoor unit that sits outside, and it's putting that heat into water rather than air on the inside of your house. So that water then gets circulated through radiators, tubes for kind of radiant floor heating within your house. A ground source heat pump is a heat pump that, instead of using air as the source outside, instead of having your outdoor unit just sitting out there and either pulling or expending heat to the atmosphere, it's using a source of water to be the source of both the heat energy and a place to dump heat when you're in cooling mode. And that ground source can be wells, a series of wells that are drilled. There are horizontal systems where they'll kind of dig trenches in the ground around your house and lay series of loops of pipe in the ground in order to kind of use the ground as the heat sink. Or you can have pond systems. If you've got a large pond or something, that can often be the source of the heat or the heat sink for this system. I think we're going to hit ground source heat pumps later, but yeah, we will. So we'll talk about the advantages. So a ductless heat pump. This is a typical indoor unit that you would get from a ductless unit, ductless heat pump, also called a mini split. And you know that. So here we go again, just saying. Ductless heat pumps, they can be either a single zone or a multi-zone. So that you know, they could be piped or set up by a contractor in different ways. A typical unit might be a single outdoor unit and a single indoor unit, like we saw in that previous picture, to heat or cool a space. But you can also, some systems, it's possible to hook multiple indoor heads to a single outdoor space to heat or cool different rooms. Well, you should talk to your contractor about that. There are some risks with that type of system about having multiple indoor heads in a single outdoor unit. The risk being that sometimes those systems can be oversized. If you're only heating one room and the other two don't need it, you've got too big of an outdoor unit. So you need to talk to your contractor, but oftentimes the most efficient method of setting up heat pumps is to use kind of a single system, or some of these other ones that we'll get to here. Okay, outdoor units. We mentioned this, but here's a few pictures of an outdoor unit. These are very typical. Sometimes they'll look like one of these that's double height with two fans on it. They are pretty impervious to weather. You can set them right outside. You don't want like the snow to slide off your roof and land on it. And you want to set it up on little stands like these so that it's off the ground a little bit, so it doesn't sit in drifting snow. But other than that, they are impervious to kind of rain, snow, hail, wind. They're meant to be outside. They're engineered and designed that way. Let's see. Indoor units, there are several different styles. One on the left is probably the most common. The one on the right looks kind of like a Rinnai heater, but that's just a floor-mounted version of an indoor unit. And I have not seen a lot of those on the right, but that's an air handling unit that's probably up in your ceiling or in your attic, and is blowing air down from the ceiling level. All those different styles are in existence out there. Okay, so a ductless heat pump, a mini split, thing we've been talking about the last several slides, is typically the least expensive way to get into using a heat pump. They're relatively fast and easy installations because they don't require a distribution system. Don't have to hook them up to ducting or install ducting. You don't have to hook them up to radiators or piping throughout your house. You just need to mount the indoor unit somewhere. Refrigerant piping gets run outside, typically just 2 copper pipes that are then with insulation around them. And you need to set that outdoor unit somewhere. They can be bolted to the outside of your house, they can be on a concrete pad, or they can sit outside in other ways. And they're a handy way to kind of like supplement an existing kind of furnace system that you might have. You can install a single ductless heat pump in a room that you're in a lot, for instance, and you can run that heat pump primarily for that room and use your heating system for other needs. And I'm not sure if we're going to hit this in later slides, but you can and generally the heat pump can be the most efficient option. If you're going to buy a single ductless heat pump like this, you might want to run it as kind of your first choice, and then use your existing kind of furnace system to kind of heat the other rooms in your house, or to pick up and aid the heat pump when it gets really cold out. That's a common kind of way to use them. Let's see. Talking about fuel switching. So if you want to completely heat your home with heat pumps, you probably it should be well weatherized, whether it's already in that state or you want to kind of put some effort into doing that. Let's see. So in generally, that's probably the first, as we said in one of the first slides, it's probably one of the first things you should think about, even if you're in the market for a single mini split or a ductless heat pump, is to first think about and consider addressing the weatherization of your house. because the better your house is air sealed, the better it's insulated, the easier it is for any heating system you have to kind of heat your house or cooling system to cool your house. The less work it has to do, this you can get by with you can use a smaller system that's cheaper, and it'll work better down to colder temperatures outside if your house is well weatherized. Well, that's always something to think about. All right. A lot of slides here. Where do ductless heat pumps work well? Again, like think about weatherization first. They work very well with a well-weatherized home. They will work with an unweatherized home, but the most cost-effective and the most effective way to make them work well is to kind of think about the weatherization first. Because ductless heat pumps don't have a distribution system, they don't have ducts, they don't have pipes kind of moving that heat around. They work best in open rooms or kind of open floor plan kind of houses. And they do work well with existing kind of heating systems to supplement, to provide heating to a particular room in the house, so that you can use less fuel and potentially save money, but certainly use less fuel, which is a goal of many. All right, ducted heat pumps. So a ducted heat pump uses the same technology. It has an outdoor unit and an indoor unit, like we've said before, and they are coupled with a duct system in your house to move that heat around. We're looking at here. So there's a couple different types. A central ducted system is going to be just like a forced hot air furnace that you might already have. So and heat pumps can use the same distribution system of ducting as your current furnace in general. They don't require different designs. So that's something to talk to your contractor about. But if you've got duct distribution in your house in good shape, you can reuse that, and a heat pump can be kind of engineered and designed to kind of hook up to that system. Ducted heat pumps have inline air filters, as do kind of most traditional fuel burning furnaces. And a ducted heat pump system is helpful for kind of distributing heat around the house to kind of different size rooms. Your contractor can work with you to balance the system well, which you would also do with kind of a traditional heating system. So you want to have the right size ducting, the right size kind of diffusers and vents in different rooms, so that you can heat a house evenly with what's often a single zone. Multi-zone ducted heat pumps are also available, where you can have more than one air handler, basically more than one blower on the indoor unit, and you can set it up with multiple thermostats and heat different rooms kind of with different demand. Or as I said just previously, you can have a single zone system and work with your contractor to kind of balance your distribution system well, and that can work as well. Let's see, sorry, I'm missing my way. Typically, they're more expensive than ductless. That is, primarily because of the, they're more expensive. The parts themselves are a bit more expensive, but the installation is quite a bit more work with the kind of the complication of that duct system throughout your house. It's best if you already have ducting in your house. It can be added, but that can get expensive. So if your current house doesn't use forced hot air, that a ducted heat pump is certainly possible, but you'd have to have an entire kind of duct distribution installed in your house, which can be difficult and can be kind of expensive. Let's see. Where do they work well? So they work well. A typical indoor unit on a ducted heat pump, it's got an air handler, and it's got the radiator on the inside, and they're typically around the size of a furnace that you might already have for a forced hot air system. So you need to have a place to put it. So a basement is a common place to put the indoor unit on a ducted heat pump system. Well, it's not the only option. They can be put in attics as well. They could be put in kind of interior mechanical rooms also. Okay. So air to water heat pump. This is like, so we've talked about ductless heat pumps, mini splits, which are kind of like the single standalone systems that heat like a room or a large area. We've talked about the ducted heat pump system, which is also called the air-to-air heat pumps. That's the one I just mentioned previously. That is distributing the heat throughout your house through forced air. And an air-to-water heat pump system uses the same kind of outdoor unit as both of the other units that we've talked about. There's really not a technical difference there. The difference is on the inside. So when you've got on the indoor unit that has that heat exchanger kind of radiator inside of it, instead of having a fan to kind of blow across that thing to either push the heat or push the cool around in your house, there's a heat exchanger to couple that to a fluid circulating loop within your house. So air to water heat pumps. So
Did you want me to step in here, Bob, with these
Oh
slides?
yeah. That would be great. Thank you. And I'll go look at the chat. So
sure thing. Yeah, Bob and I were going to break it up a little bit here to deliver content tonight, and I'll step in here to talk about the air to water systems and geothermal systems. So as Bob was just kind of alluding to here, so far what he's covered are the air to air type equipment that are available in the market. And the refrigerant process, again, is moving heat energy from one source to another through the refrigeration process, through compressing and releasing the pressure and the heat energy within the refrigerant from one side of the cool side to the hot side, or hot side to the cool side, depending on which way you're using it. So the two types that Bob has covered so far are the air to air type. So in that process, you're blowing air across the hot refrigerant coil, either in the ductless head that's going to be in the room or through a coil that's within some sort of forced air ducted system to deliver that air through the room. So both of those types are moving the heat energy from the refrigerant process by air throughout the building. The ductless system is really kind of should be considered like as a space heater, because you're only able to, condition the space that heat that piece of equipment can see, quote unquote, in the room. So those do kind of work within a home, similar to what you'd have with either, vented through the wall space heaters that are propane, or a wood stove or something like that. You can use them to heat up to a full house, depending on how many of them you put in the house, but you're using them space by space. The ducted systems, as Bob was saying, there's a variety of different ways you can put that air source heat pump into the home's distribution of an existing ducted system, or there are standalone compact ducted heat pumps available as well that can do portions of a home. So you can do, put a small duct system in that feeds 3 bedrooms and a bathroom off of one air handler off of the heat pump. So what we're stepping into now with the air to water systems is more of a whole house system. And this is where we're integrating a heat pump and the refrigerant process into distributing heat energy fully throughout the whole home. So the air to water equipment is using the same outdoor condenser type that we're going to be using for the other types of heat pump equipment. So the actual outdoor unit will look pretty much the same as it would for a ductless or a ducted heat pump, but the heat exchange is different. That hot refrigerant that's being created by the refrigerant process outdoors, extracting that heat energy from the outdoor air, instead of it being brought into the house and then having a fan blow air across that hot refrigerant coil to move heat energy into the room, an air to water system is taking that heat energy and providing heat exchange and heating water and heating a storage tank of water. So this could be considered and thought of as a boiler, to what Bob shared at the beginning of the slide content here. This is what essentially a heat pump boiler to be used in the home. Fuel-fired boilers, as Bob had mentioned, are high heat systems, so they're designed to deliver a higher temperature water throughout the distribution system that's going to be in the home, while any type of heat pump equipment is considered low temperature distribution and low temperature energy that is being created here. So there's a limit to the amount of heat energy that can be created with the refrigerant process, what we have available now. So That just means that when you're considering using something like an air-to-water heat pump, you have to have a distribution system in the home that is matched for what the heat pump is able to deliver. So utilizing an air-to-water system, you do have a lot of flexibility into then how you distribute that heat energy into the home. So with an air-to-water system, because of that heat exchange and the fact that you're just maintaining a tank of hot water with that heat pump, you can provide distribution through forced air. So you can have a coil of hot water in a forced air ducted system. So you can be distributing your heat energy that way. More commonly and most predominantly with air-to-water systems, you're using hydronic distribution. So that would be what Bob mentioned earlier of baseboard, heaters, radiant heat, radiators. And then also manufacturers have the same type of ductless wall mount heads that Bob showed you with the ductless equipment. And the difference there is that you're running water, hot water, through the coil in that ductless unit on the wall rather than hot refrigerant. And in this situation too, with an air-to-water system, that heat pump can chill the water that's in that storage tank as well. So with a ductless head or a forced air system in a building using an air-to-water heat pump, you can do both heating and cooling with that type of equipment. But most predominantly what we're seeing is using an air-to-water heat pump in a hydronic heating system with traditional types of hydronic distribution through the home. So this is just showing you an example of what the what type of equipment we can talk about being integrated here. Again, it can be a ducted system with an air handler that can do heating or cooling, and that be your full and only system for distributing the heat energy in the house. Or it can be a piped water system throughout the house. And with that piped water system, you can have a variety of different emitters, as they're called, throughout the building. So this could be baseboard in one room. It could be a floor freestanding radiator in another room, and it could be a radiant floor in another part of the house. There's a lot of design flexibility with this equipment. So there's specific emitters, as we're calling them here, for distributing that hydronic heating throughout the home that are specific to low temperature water. And these are products that have been available on the market for a long time. But more commonly, what we have in our housing stock in the Northeast, we do have a lot of hydronic heat, but it is designed around higher temperature water. So air-to-water equipment is something that you can be looking at as if you're adding on to your home, if you're designing a new home, you can really 100% design a system around using that air-to-water heat pump with low temperature distribution throughout the whole building. Into an existing building, though, it does take another layer of evaluation to understand and determine if what you have for distribution in the house is going to be able to work with lower temperature water moving through it. So that is a factor that comes into play with considering air-to-water systems for existing buildings. One thing I will say is that, and some of the questions that we got that were submitted to us prior to the webinar here tonight, were asking about changes in technology and refrigerants with heat pumps that are coming our way. And there are some changes on the horizon for different refrigerants, the actual refrigerant gas material that is used in the heat pump to do the energy transfer. Some of these new refrigerants that'll be coming into play with upcoming equipment in years ahead have the capacity to put out higher temperature water and may find a way to be more, have a broader match to existing distribution systems here in Vermont. But there's a lot of flexibility with using this type of system when you get into the design of the distribution. So it can work in an existing home. It's something that's definitely can be considered for new construction. And again, it takes working with a contractor who has the ability to do that full outline of evaluation of what the loads are for the house and what the actual existing distribution is capable of doing for heating. But the equipment types, for what they look like, this is just an example of what the outdoor unit would look like, and then what the indoor system looks like. So the outdoor unit, again, looks similar, if not just a little bit bigger than a ductless heat pump outdoor unit would. And then inside the building, you have that box that's mounted on the wall up there is where the heat exchange occurs from the refrigerant to the water. And then that tank right there is your thermal storage tank. That's what the heat pump is doing, is it's maintaining a set temperature in that tank. And then that water from that tank is being sent out into the distribution system throughout the home. So this is a whole house system versus kind of, the individual room type system you'd be looking at with a ductless or a compact ducted heat pump. So you can do your whole home. With this type of equipment and with the right design, it is possible to do domestic hot water off of the heat pump as well. So again, thinking about this, if you have a boiler in your home right now, an oil or a gas-fired boiler, and you have an indirect hot water heater off of the boiler, the thermal storage tank off of that boiler, the same type of concept of design can be put into place with an air-to-water heater. Takes careful design and takes a few layers of process, but that's capable with this type of equipment. And there's considerations to come into play again about what you can do and what you can't do with the existing distribution you have in your home. So to that point, it's not typically a plug and play for existing homes, but it can be done with if the conditions are right. Again, as we've talked, which is relevant to on any of this type of equipment for an existing home, the more you can do to lower the loads in the building by doing weatherization and improving the building thermal envelope, the better match any of this equipment is going to be for your use, for your comfort, and for the efficiency of the equipment. So once you dial those things in as best as you can start looking at what is going to be your best fit and your best options for, what you want to accomplish with a heat pump. Do you want to do your whole house? Do you want to use the existing distribution, or do you want to use room by room heaters? What type of equipment is a good match for getting to those outcomes? Radiant floors, if you have a radiant heating system in an existing home, oftentimes that can be possible to retrofit an air to water heat pump in because radiant floors are a low temperature type system in the first place. So that is something to be considerate of. If you know that you do have radiant floors in your home and it's currently a fossil fuel fired system, that could be a possibility to be a little bit more of a quote unquote plug and play retrofit with an air to water system. And now this brings us to our final heat pump technology we'll talk about here tonight, which is ground source heat pumps. Now again, ground source heat pumps are kind of, again, iterating towards a whole house system. So looking at the ground source is simply just the heat source or the heat sink that the refrigerant process is using to pull its heat energy from or to extract the heat energy to, depending on which mode it's in, heating or cooling. So geothermal heat pumps is another name for these, ground source, but essentially what we're talking about here is the other three types of equipment we just spoke about, ductless, ducted, and air to water, is using air as the source of the heat energy or the heat sink for heating and or cooling, depending on which cycle we're using the heat pump in. Ground source is using the ground. So one of the benefits of a ground source system is the stable temperatures of the earth and the ability to extract consistent levels of BTUs of heat energy or dump consistent levels of heat energy back into that ground source throughout the year. An air source heat pump, its efficiency, its potential output of BTUs is going to vary depending on what the outdoor air temperature is. The warmer the outdoor air, the more efficient it's going to be and the more heat energy it's going to pull. The colder the air, the less. That being said, any of the cold climate heat pump equipment that we have rebates available for and that are a part of the programs that we promote is equipment that works still very effectively at temperatures below zero outdoor temperature. Now, that being said, a ground source system is going to offer more consistent temperatures throughout the year. It's going to offer more consistent levels of efficiency for operating the system, but it's also more infrastructure, significantly more infrastructure involved in putting one of these systems in. You are digging into the earth. Most commonly, the type of systems that we see here in Vermont are going to be drilled ground source wells. And they're going to be one of two types typically, a closed loop or an open loop system. Now there's other types of ground source or water source heat pump systems you can do too. You can put that refrigerant coil into a water source, into a pond or a lake. So that is done here in Vermont, but not often. So most typically what we're talking about in the geothermal and ground source space here in Vermont is these ground drilled well type systems. A closed loop system is essentially that. It's a closed system where you're drilling X number of wells to X number or to a certain depth, depending on what the load needs to be for the home. And then you're running a loop of piping into those wells. So it's actually, you're putting plastic pipe down into these wells that is one continuous loop from the heat pump back to the heat pump. And you fill that tubing with a glycol and water mix, and it stays closed off from the outdoor environment. And that's, you're cycling that water and that glycol loop through the ground as your heat sink and heat source. An open loop system is same process of drilling a well, but you're just moving water into and out of that well through the heat pump and exchanging the heat energy that way. Coupled the variations in performance between the two different types. With an open loop system, you can utilize existing wells or water wells. Water quality has a huge factor in doing open loop systems, the type of water that you're actually pulling through the system. So if you have hard water or minerals in your water, that can be a problem to do an open loop system. But the big thing that you're investing in here that's different than the other types is the drilling and the ground source that you're going to be using and utilizing for the heat pump system. So this is where the expense of the system can be impactful. I'm having a hard time. There we go. You can get really good consistent COPs, efficiency throughout the year, and really good BTU output throughout the year. Again, this is a low temperature water distribution type that we're talking about, similar to the air to water. These ground source loops can be connected to existing systems, or they can be built as new. It is pretty common for ground source systems for an existing building to be integrated into a forced air system. That's a pretty common application where you're actually putting a ground source refrigerant coil into an existing forced air furnace, and then that is being used for the primary or secondary heating for the house. So you have a lot of flexibility again with the ground source system, as you do with an air to water, about how you distribute that heat energy in the building. It can be hydronic, it can be forced air, it can be a variety of different distribution types. But again, it does have to be designed around the heating capacity of what an heat pump equipment can do. So it has to be low temperature design to make this work. So these are decent fits for large homes, you know, that you've done, again, work on the thermal envelope to reduce the load on the building as much as possible. If there is a old boiler that is starting to fail, you know, this could be an opportunity to look at integrating ground source heat pump to either take up most of the load of that boiler or potentially all of it, again, depending on the distribution in the home. The forced air system, it can be integrated a little bit easier. You have to make sure that you have the site and the local zoning in some situations too to allow for this to work as well. And similar to the air to water heat pumps, if you have existing low temperature distribution in the home, then it makes integration of a geothermal heat sink that much easier and the way to adapt this equipment into an existing home. Again, if you're designing a new home from ground up, you can look at ground source heat pumps as your option for doing your full load capacity heating for the home, just like you can with the air to water. And so now just to summarize here quick, and then we'll talk about financing, rebates, and get into questions. So ductless and ducted systems are central or decentralized for depending on what the orientation or duct type is that you're going to be integrating a heat pump into if you're doing a ducted system. Otherwise, ductless systems are kind of space heaters, and you can use one or more of them within a home to accomplish your goals with utilizing a heat pump for taking up heat load and or increasing comfort in portions of your home. And air to water and ground source systems are whole house, fully distributed heating systems that can be done either hydronically or with forced air distribution. So the As Bob mentioned at the beginning here too, the ductless systems are going to be your most lower end of the spectrum as far as cost and ease of installation and flexibility. Ground source is the other side of the coin there as far as cost and complexity for installation and design. So how to get started in getting a heat pump installed, you really got, and this is where kind of the questions that came in speak to some of these things. A lot of these questions that are here in front of you right now are the things that do need to be considered and, guide the process of how you go about choosing what to do with heat pumps. Are you seeking this to increase your comfort during shoulder seasons? Are you looking to try to replace the use of an old ducted through the wall heater in your room or an old wood stove that you don't want to deal with the wood anymore? You want to try to get all off of fossil fuels and replace what you have in your home fully with heat pumps? All factors that would go into, what your choices are and which direction to take with the different types of heat pump equipment available on the market. Again, looking at the building thermal envelope as a primary objective to get after ahead of doing any sort of equipment installation is also the best place to start and to consider your options from there. To that point, Efficiency Vermont has available and has been doing this for quite a while, offering a free virtual home energy visit. So you can reach out to Efficiency Vermont with any questions you have specific to heat pumps or just to your overall situation in your home and just kind of help to dial in some of your options and some of the places as priorities. So this is a way to have a one-on-one consultation with one of our energy experts to talk through all the specifics to your home, give you some feedback on what your existing conditions are, and provide you with resources of where to go from there to start to move into putting a project together and getting connected to contractors. And handily enough, as noted, we have a Find a Pro tool on our website, which is a way that you can find all of the contractors that participate with Efficiency Vermont through our Energy Efficiency Excellence Network, the EEN. So these are all contractors in various trade groups that have partnered with Efficiency Vermont and have agreed and share a mission with Efficiency Vermont for installing efficient measures and equipment in homes and have access to the home energy loan through Efficiency Vermont and other exclusive offers and membership access that distinguishes Efficiency Excellence Network contractors from other contractors. So that's the best place to start, to try to find whom to reach out to start to put the project together. And these are some things to consider when reaching out to a contractor. Find out there's different contractors will install different types of equipment. So get a sense of what they do. You can find that through our Find a Pro tool as well. That'll help tell you in that tool, what types of heat pump equipment that they install, what their service area is, and their own summary of what the work is that they do. Some contractors will go beyond heat pumps and do weatherization and other more whole house, whole building energy work as well. Asking about long-term service and maintenance of equipment. Heat pumps are a low maintenance type piece of equipment as long as it's kept up with. They don't need the same level of annual servicing and maintenance that fossil fuel equipment does, but it is important to know whether the contractor you're going to work with will be able to provide that servicing and maintenance over the lifetime of the equipment. Well maintained, this equipment can last for a very long time. I've seen heat pumps that are 25 years old still working in buildings. So simple equipment, simple technology, and as long as it's maintained, it can last for a very long time. Efficiency Vermont has a whole bunch of offers and incentives for heat pump equipment. So pretty much any of the heat pump types that we just discussed, there are offers available from Efficiency Vermont and from our partnering distribution utilities for heat pump installations. So this was just a summary here of what the different types of equipment have available for rebates currently right now from Efficiency Vermont. Again, this is something to look up on our website. You can also find further information there about income qualifying bonuses for this type of equipment too. So these are just the standard rebates that are available. And then we do have quite a few other programs from Efficiency Vermont and through our partner distribution utilities that are income eligible and financing as well in that regard. for installing this type of equipment. One thing we did not focus on here tonight in this content, but is the question that people have asked as well, is heat pump water heaters. Heat pump water heaters use the same refrigerant type technology and the same refrigerant process to create heat energy to heat hot water. The heat exchange is going from that heat pump into the water storage tank. So that is another product category that we have point of sale rebates on, and then again, other offers available for income qualifying households to get heat pump water heaters installed in your home. Federal tax credits also apply, but speak to your accountant or look at what your tax situation is to see how you'd be eligible for those offers as well. Working with a efficiency excellence network contractor, you would be able to have access to the home energy loan, which is a low interest to zero interest loan product that's available through partner lenders that are listed on this page here. So this is an opportunity to be able to borrow up to $20,000 for qualifying products and programs to install those measures in your home. And depending on where you land in the income categories, you can finance that to 0% interest for 5 years. Again, this is exclusively available through Efficiency Excellence Network contractors. So if you are interested in this program, that's who you'd be working with to access that offer. We have a deeper level of program offer called the Weatherization Repayment Assistance Program. This is working with a subset of weatherization and home performance contractors and other contractors in the EEN that basically is intended to be a comprehensive retrofit for a home that involves weatherization and looking at then doing weatherization and including efficient heating, cooling, and water heating products installed in the home as a part of that project. And this is an opportunity to be able to repay the cost of financing that project through your utility bill. So the whole project can be financed through that program. So if that's something you'd be interested in as well, we have some contractors that are working with us specifically in this program. And now I'm going to pass this off to Bekah, and she's going to give us an update on upcoming webinars, and then we'll get into the Q&A.
I can apologize. The F-35s are flying over right now, so I can't hear myself, but
Perfect
hopefully
timing.
you can hear me. I know, perfect timing. Well, first of all, just thank you, Bob and Steve, so much for that content. I feel like every time I listen to one of these webinars, I get a lot out of it and learn something new. So thanks for that. I just wanted to note that we have some upcoming Weatherization Wednesday webinars. So we're hosting both this webinar and the Weatherization 101 webinar twice throughout the month of October. So we already had our first Weatherization 101 webinar October 9th, but we are hosting that again next week at noon. So Bob and Steve both mentioned how important it is to weatherize your home, and particularly before installing a heat pump to really maximize the use of a heat pump. So if you're interested in weatherizing your home and haven't done that, that's a great webinar to attend. And then again, we're hosting this webinar on the 30th at noon. Most of you probably will not be joining that unless you want to hear the content again, but just wanted to flag in case you know folks that really wanted to be here tonight but couldn't make it, let them know that we are hosting something again. And then I also just want to know at the buttonupvermont.org /events, you can see not only the Weatherization Wednesdays, but also a lot of events that local communities are hosting across the state. So there might be an event near you that you might want to check out. And then I think we have a few minutes for Q&A. It looks like most of the questions that were in the chat got answered by our panelists or some other of our colleagues. So I will just kind of talk about some of the themes and some of the questions I am seeing here that came in through registration. Hopefully Steve and Bob can kind of chime in on some of these themes. So some of the things that we heard a lot, especially in the questions coming in registration, were just the compatibility and integration with current heating systems. How does that work? A lot of questions about, you know, if a heat pump will actually save you money. Several questions about installing heat pumps in mobile homes and what kind of heat pump system works best for that. Again, heat pump hot water heaters, which Steve, you touched on. And then we had some questions I saw recently about what happens during a power failure and how do heat pumps work in those conditions. So.
I just answered that one in the chat.
Oh, perfect. Okay.
But I say it out loud. So
Perfect.
yeah, in a power outage, if you don't have backup power, heat pumps run on electricity, it will shut off. But the fact is that almost every fossil fuel heating system will also shut off. So fossil
Yep.
fuel heating systems, your thermostat requires electricity. That alone will turn it off. But if it's a forced out air system, it needs an air handler with a fan. That certainly needs electricity. And even with radiators or radiated floor heating, those have pumps, and those pumps run on electricity. So it's a
Your
similar
backstop is a
situation.
wood stove.
Wood
If you,
stove. I have a pellet stove.
it's a generator or a wood stove,
Yeah,
that's what'll get you through.
that's what gets you through. I have a pellet stove. The pellet stove requires electricity, but it doesn't require much. So I hook it up to a little bit of to either a little generator or actually hook it up to my car,
Yeah.
and I run my pellet stove when my heat pump's off.
Yeah, and that is something that comes up about concern about running a heat pump off a generator. And so, it is possible to run a heat pump off a generator. You have to have, again, a generator sized appropriately to meet that match. Frankly, heat pumps do not draw a lot of electricity when they're coming on and operating, because that's why they're so efficient. And that's why we are promoting the use of heat pumps, is because when they come on and operate, it takes very little electricity for them to just kind of cruise along and modulate to meet the needs of the heating of the house. Unlike a fossil fuel fired furnace or boiler, which comes on and it cycles up and down, and it uses a lot of energy quickly and then goes off, and then uses a lot of energy quickly and goes off. A heat pump just kind of moves along steady state, kind of cool and steady, keeping things right, keeping everybody comfortable. And in that process, it takes very little electricity to run the pumps and to move the refrigerant through the building. So it's not a huge electrical draw when the equipment is running to run it. But again, if you really want to cover yourself, generator or a wood stove is the backup plan. Integration with heating systems too. We talked about the physical integration of heat pumps with physical distribution of the building, but the other reality of this too is how to use a ductless heat pump typically with an existing heating system. So yes, it is possible to in homes to put X number of ductless wall-mounted heat pumps into a home that could meet the full load of the building if the building is adaptable to that for its energy use, and the heat pumps are sized right. That being said, most often you are going to keep the existing heating system in place to pick up any load where the heat pumps either are not keeping the house comfortable, if there's not enough of them, or it's just not laid out right to do that. Or also you can look at your electrical use compared to your fuel costs. That's another way of evaluating when to use a heat pump or how much to use a heat pump compared to what your existing whole house fossil fuel system is doing.
So I
there's
tried to
a
answer one of
variety
those
of
in the chat.
ways.
Somebody asked about using the heat pump because I mentioned something about using it in conjunction with an existing furnace system. And one way a lot of people would do it is a kind of a way to wade into the world of heat pumps is to put a mini split in a common used room. And the intention is not to run both at the same time. The intention is to set your thermostat so that the heat pump comes on first and runs. And if the heat pump can't keep up, if your temperature is dropping and you're not hitting your set point, you put the thermostat setting on you set the thermostat on your regular furnace to kind of kick on and take over and or help when those temperatures drop. But you'll often find that heat pump can handle almost all your kind of heating needs.
Yep.
And it will be likely cheaper, especially at modest outdoor temperatures. Heat pumps are maximally efficient when it's like 40 or 50 outside. And they're still pretty efficient when it gets down to really cold, but the efficiency
Yep.
does drop as it gets
It
colder
all
out.
depends on what you want to accomplish with them, right?
Yeah.
And a lot of the feedback that we get from consumers and contractors as well is that these are the times of year that they really rely on their heat pump, is they use them completely in the fall through December into the heart of the heating season, and then they'll just decide to just use their existing heating system until it gets to be March, April, and then they're relying on the heat pump again, and then it's there for cooling during the summer as well. Or we also hear that people have installed a heat pump or a couple of them in the house for cooling, and then they find that they're really handy and nice to use during the spring and fall as well, and you realize fuel savings and increased comfort at the same time. with that
And
use.
if you want to get entirely off fossil fuel, you can do it with a heat pump. There's a lot of examples of that. My own house, which is not the best weatherized house because it's 240 years old. I run solely a heat pump with an electric resistance backup. So, it was sized by a contractor to kind of like heat the house when it got down to about 5 degrees Fahrenheit, which is kind of a typical design temperature for a heat pump heating system. And below that, it includes a resistive kind of a electric resistance thing within the air handler that runs off 220. It's wired in, with the rest of the system, and that supplements it and creates heat. So I choose to just got rid of my old furnace. So that is possible if you want to do that.
All right.
And they can be used in mobile homes too. That was just one other quick theme I didn't want to lose before we ended here. Yes, that they have to be sized appropriately to the space, but 100%, ductless wall mounted heat pump can be very advantageous in a mobile home.
Great. Thanks for reminding that, Steve. It looks like there might be a few extra questions in the chat, but it is 7 o'clock. So if we didn't get to your question, please follow up with us. We have a great customer support team that can answer your questions, or you can sign up for a virtual home energy visit. But again, just want to thank our panelists for a great presentation and for everyone who showed up and put in their great questions. Again, you can look forward to a recording as well as the slides and the chat for all the great answers that were put in there as well. So thanks everyone and have a great evening.
And please reach out to us at the numbers here and take advantage of the virtual home energy visit as well and check out that Find a Pro tool.
Great.
Thanks.
Bye, everyone.
Thanks everybody.